Okay, recording started. Welcome to the January 10th, 2013 study hall. Again, this is a continuation of a study hall theme that we first had about 2.5 years ago, which was problems on which algebra is either difficult or impossible. In most cases, that's impossible, so the idea here is to broaden your skill set to extend beyond your traditional kind of school math skill set. So in any case, that's our topic. What we have to do first, though, as usual, we have to go through all the rules just to make sure we're all on the same page with how this works and how this doesn't work and everything like that. So if you are an old timer here, you'll know all this stuff already, but we do have to go through it each time just to make sure everybody's on the same page. So let's do that. The problem submissions. Again, please don't submit things that are too general. We've got a lot of people doing this lately. Seems to be more than usual, so, please don't. Please don't submit things that are like half the test at once, So like, how do I do all of geometry, or how do I solve problems faster? A good guideline is this. Topics that can last 60 to 90 minutes. So something like how do I solve problems faster would be, hours and hours and hours and hours, because that's every type of problem on the whole test. Same thing, we can't really do all of geometry in 60 to 90 minutes. At the same time, the other extreme is also not so great. Please don't submit problems that are too specific. Those are the reason why we have forums. There's the address for the forums. So if you're just asking about one problem and a couple of answer choices and so forth, then please post those on the forum. Again, if it would only need a few minutes, please go to the forum. We're trying for the sweet spot here. We're trying for topics that make legitimately coherent class topics, so 60 to 90 minutes, but are not, single problems. And then last but not least, please don't submit personal issues. So don't submit your scores or your profile. And also no admissions questions either. We are Manhattan GMAT. We're not an admissions consultancy, although we do partner with one. So if you do have questions about admissions, this is the place to send them, the Ask an Admissions Consultant folder. So as far as the topics we should see on here, intermediate depth, try to follow this guideline. A topic that could last 60 to 90 minutes is a good topic. If you have specific problems, great, but please try to tie them into a more general question. Because again, if you just have a specific problem that is not really tied into a larger theme, then the best place to go with that is our forum. That's actually the reason why we have the forum. Okay, finally, no official guide problems, and wherever your problem does come from, you have to say where it is from. You have to please cite the source. Thank you very much for this. Copyright is, it's a very big deal in this sphere. GMAC protects its copyrights rather aggressively, as do some other entities in the field. And also, we would like to know where the problems come from. The authenticity is also an issue. So if you don't cite the source of a problem, then unfortunately we can't use it. That includes problems from Manhattan GMAT. We have about 5,000 problems in our bank, so we don't recognize them all by heart. So always tell us where everything is from, please. Okay, here are some recent submissions that are bad things. This one was submitted a couple of days ago, but here's my undergraduate, and my graduate degree is in this, and what's a good strategy, admissions with this GMAT score. What's a good strategy for the GMAT is much too general of a question. And then what's a strategy for applying for an MBA? Again, that's an admissions question. That's something you would want to post on the Ask an Admissions Consultant folder in our forum. This problem is one specific question from data sufficiency, and this is a perfect forum post. This is someone asking about one question and a couple of answer choices, so you would just want to post that in the forum. And then finally, official guide problems, you can't use them. Some people are still submitting official guide problems, which is interesting because when you submit problems, you see this dialog box. You should see something that actually says, please do not submit these. And so, you know, that's not a joke, ladies and gentlemen. If you want official guide problem help, we cannot do it here or on the forum. So that's by express request of GMAC. So we have to honor that very seriously. Another thing, the archives. At this point, there are somewhere, I think, between 70 and 80 archive sessions of this program. So the archive is very extensive. It covers a lot of topics already. So please check the archives for topics before you post them. We get quite a few submissions that are basically duplicates of already existing topics. So if you want to submit something that has already been the topic of a session, what you should please do is give us some sort of new angle on that topic or some sort of aspect of it that has not already been treated. But go ahead and please watch the archived recordings first for the topic that you would like to submit. The archives are just further down. All you have to do is scroll down the same page that Thursdays with Ron is on. So scroll down and you will find this. It's a treasure trove of recordings for all to enjoy. So please check that out before submitting a topic. You know, you may find that your desired topic is already right there. Okay, those are the rules. When we say give me a smiley face, you should find the face icons over there on the left underneath your name. When we say give me a smiley face, I'm going to have you do that at various points here, just to make sure that you're on the same page with me before we move on. When I make that request, please don't put a smiley face in the chat box, because that'll get very, very overwhelming very quickly. If there are, 40, 50 of you guys putting faces in the chat box. So please go ahead and give me a smiley face at this point if you understand the rules, please. Smiley face. Okay, that's a lot of you guys. All right, thank you. And all right, so when you have multiple choice options, these are all going to be GMAC problems except when indicated otherwise. So there's a couple there from our materials. So let me add that little note. These are all copyright GMAC except when indicated otherwise. You can feel free to distribute GMAT prep problems. It's the same reason we're allowed to use them here, because it's a free software. It's freeware, you can distribute it for free and so on. But GMAC does request that if you do distribute these questions, that you distribute them with this copyright notice. So unless we say it's from our sources, it is from the free GMAT prep software from GMAT. And please don't distribute OG problems. When you get multiple choice questions, you will see 5 multiple choice options underneath your name. Please use these options to answer the multiple choice questions. Please do not post your answer in the chat box. Because number one, again, we can't have 50 people posting in the chat box. And number two, if you do, it'll influence everybody else's answer. When you use these options, your response will not be visible to other participants. And so everyone will get their own shot at the problem. Finally, the actual GMAT test does not let you skip problems. So, I mean, I can't really enforce this on you guys, and if we wait long enough, we'll just move on. But make sure you don't not answer the problems. Like, make sure you don't abstain or like not answer, because that's not an option on the real test. When you take the real test, you must answer every question consecutively, or you can't move on. So make sure that you start schooling yourself in that sort of way. Okay, everybody give me a smiley face if you are ready to move on to some actual problems. All right. So again, just to make sure we're on the same page here, for those of you who just came, the topic for today is more problems on which algebra is not your friend. So here is first problem of the day. Go for it. This is from our CAT exam questions. This is not a GMAT prep problem. Okay, here is a timer. Go for it. Okay, everybody try to get an answer in the next 10 or 15 seconds here. Remember, if you have to guess, you should go ahead and guess, because that's how this exam works. So, okay, 5 more seconds again. Just take a random guess if you've got to take a guess, but get an answer on the board, please, and then we will get going on it. Okay. All right, so here are the answers of the class. So it looks like people, I mean, there's still 10 non-responses. Only one of those is me. So if you are one of those 9 other non-responses, please don't do that when you practice. You have to just let it rip. But it looks like of the people who did answer the question, it looks like people are fans of E. It turns out the answer to this problem is not E. In fact, it's not either of the 2 decently popular answers here. So looks like we got some learning to do here. In any case, as you may have deduced, it's not really possible to do this problem with algebra, because you would have like 7 unknowns. So if you tried that, hopefully you would have gotten out of there really quickly. So can't use algebra here because there would be way, way too many unknowns. So, and there's also another clue, which is that they were all different integers. When you have integer restrictions on things, as we will variously see, it's a pretty good hint that you should be taking an approach other than algebra. So what we need to do here is we need to just look at specific cases. But first, let's just make sure that we are on the same page with what we're trying to do here in the first place. So the question part of the question is, what was the price of the most expensive appetizer? So just to make sure we're on the same page here, before you even start this problem, let's talk about what you should do before you even start a data sufficiency problem. Make sure you understand exactly what would sufficient mean and exactly what would insufficient mean. So, I mean, don't proceed to solve the problem until you actually have ideas of these things. So in the chat box, someone tell me, the question again is, what was the price of the most expensive appetizer? So someone in the chat box, can you tell me what would it mean if we got an answer that was sufficient to that question? What would it mean? I mean, yeah, we would have a, this is not a yes/no type of question. This is a one value type of question. So if there is only one possible value for that price, then that's what sufficient means here. And then what does not sufficient mean? It means there's not more than one. It means there's more than one. It means there's not just one. So more than one possible value for that price, then not sufficient. To make sure you get this in mind before you proceed here, because otherwise it's going to be very, very difficult. So there's that. All right, so there's that problem. Let's go ahead and take the problem to the next page real quick. Okay, so here is the problem again. So let's organize this. We do have the fact that every entree costs more than every appetizer. So in other words, all three of the entrees are the most expensive items. 4 entrees. All 4 entrees are the most expensive items, and then the 3 appetizers are the cheapest item. So let's put the entrees in, I don't know, let's say the color of a steak. Let's make 4 blanks for those. And then those will be our entree prices in that color. And then I'm thinking appetizers, I'm thinking maybe like vegetable appetizers, so let's make those green. So 3 blanks for the appetizers. So let's make this in descending order from left to right. So this is another principle here that, you know, you may not see it explicitly laid out as often as it should be, because it's just kind of implicit in a lot of people's treatment. But you should organize everything that is a word problem. Like, you should definitely figure out what's going on. Like, what's in the situation first, get it on the same page, make some sort of organizational device. So this is key. Organize. Organize. Like, whenever you have a word problem like this, on just about any word problem, you should try to make some sort of organizational scheme before you begin. Because if you don't, it's just going to be way too hard. I mean, it doesn't have to be anything super fancy. You know, this is just 7 blanks. But 7 blanks is still an organizational scheme where you have the greatest here and you have the least here. So, okay. Number 1, the most expensive entree costs 16 bucks. So let's do that first. And don't forget to indicate the actual answer to the problem, which is this is the most expensive appetizer. So don't forget to do this. Don't forget to indicate which one you want. Because remember, you do not have to find all 7 prices. Big mistake. A lot of people would approach this thinking, oh my gosh, I have to find all 7 of these prices. Well, guess what? No, you don't. So, very careful with that. Okay. Any questions about the organizational scheme? Okay, so let's look at statement 1. Statement 1 says the most expensive entree was $16. So let's just start laying out cases here. So if that was 16, what are some possibilities for the other entrees? And someone give me a possibility for the next 3 entrees. Remember, the prices have to be all different. 15 for the next one, 14. Sure, let's try that, right? So if we do that, then that means that this is a total of $58. You need a total of $89, which means that 58 taken out of 89 is $31. here. So let's see how we can get that. Well, one way to get $31 is to put a 12 here. And then we're left with $19, so you can do that with 10 and 9. You could also do that with 11 and 8. But again, notice that that's not two answers for the box that we want. So the idea here is to try to get something other than 12 in this box. So just make sure you're aware of this. Like if we can get any number other than 12 in that box, then not sufficient. But if we can't, then sufficient. I mean, this is some people, this is the biggest problem they have when they do problems like this, is they just don't keep track of this strategy stuff. Like they forget what they're trying to do halfway through the problem. And I mean, you have to have a goal in mind as you go through this process. So, well, let's try to do that without changing the entree prices and see if that gets us anywhere. So if we have, if we do this, let's keep the 16, 15, 14, 13. So still need $31 here. Well, if we try to do $11 here, then we only have $20 left here. We can't do that because you would need to put a 10 or less and a 9 or less. So you can't make this work. So our only hope here is to try to actually change the price of the entrees, but let's see if we can do that. So if this is the most expensive entree, so you can't make these numbers go up. So the best hope you've got here is to try to make one of the entree prices go down. And the smallest change you can make in the entree prices, because you can see what the issue is here, right? The issue is that the appetizer prices are brushing up against the entree prices. So you don't really want to make a huge change downward here, because then it definitely won't work. So let's just make the smallest possible change we can make, which is let's leave these as 16, 15, and 14. Then let's just make this 12. So that's the only thing we're actually changing at the moment. Let's see if that works. So now this is total $57. Well, here this is going to be 89 minus 57. So that looks like it's $32 that we're supposed to have. But this would have to be 11 or less. This would have to be 10 or less. This would have to be 9 or less. That's not going to work because that's only $30 or less in appetizers. So this can't work. So guess what, folks? Statement 1 is sufficient. You actually can't get any price for that appetizer other than $12. So the most expensive app must be $12. Sufficient. Statement 1 is sufficient. Any questions about that? Go ahead and put them in the chat box. So notice Ram says no. Is that a no to something on the board, or is that some sort of just no, I don't have any questions? If it's no, I don't have any questions, then you don't need to comment on that. But otherwise, if you do have a question, feel free. But notice that something here, I mean, almost everybody got statement 1 wrong, because we are now down to choices A and D. And collectively, only 6 out of 41 people picked those. So this means that for at least 35 of you, there's something here to be learned. So just make sure that you are paying attention to what's going on here, because there's a lot of stuff happening here. Organization is probably part of it. Like if you didn't organize this, and again, organizing can be humble. I mean, the only sort of organizing I did here is make 7 blanks, but even that is a big step. So if you didn't do that, I think you see what the problem here is. So there's that. And then there's this whole issue of testing numbers in the first place. If you attack this with algebra, you will not win. So the Albert says it seems like a lot to do in 60 seconds. Well, you don't need to do it in 60 seconds. I mean, remember that longer problems you can take more time. You know, like taking 3 minutes on this problem is not a big deal, because then if you get some little short problem, it would take less than the average. You know, 2 minutes is not a time limit. If you think that it is, then you just won't finish any problem that is long. So be very careful with that kind of thinking. But not really. I mean, this is not a lot of effort. I mean, this is just subtracting and adding numbers, and you can take more than a minute to do it anyway. So there's that. Okay, any other questions on this? Also, Albert, if you, this is one of our Manhattan GMAT problems, but if you, so let me just summarize the comments I made in the last minute or so. First comment is you don't have to do this in 1 minute, because remember that longer problems can take more than the average time. Doesn't mean what an average time is, right? It's an average. I mean, one of the worst things that you can do here is think that you have to solve everything in the average amount of time. I mean, if the problem is definitely longer and more involved, then you can take longer. I mean, it's pretty much common sense, but just make sure that you use that common sense. But also, there is, for a similar official problem, you can Google for a GMAT prep problem that starts with, let me find the reference for you here. There's a problem that is decently, I mean, we still have to do statement 2, so we're not totally done yet, but it starts with these words. This is the question part of it. So Albert and others, this is a GMAT prep problem that is a lot like this one. If you want to find that problem, you will find that it will definitely take you about the same amount of time. And again, if you limit yourself to 2 minutes, you're going to be in trouble. We also did this problem in the November 4th, 2010 study hall. So you can look for it there too. Someone, Rena, says this. This is a good insight, yes. This is a valuable insight, yes. Because if a problem is restricted to whole numbers, then algebra can't really tell that difference. Like there's no way to make that distinction with algebra. So just make sure you know that. If you see like these things have to be integers, and then you see a whole bunch of other facts about them and stuff, then what you should be thinking is, okay, yeah, then I might want to think about doing not algebra here. As far as another way, there's not really on this one. So let's take a look at statement 2. So here's the question again. The question is here. So statement 2, let's use the same sort of blanks. The least expensive appetizer was $9. And again, what we are trying to do here is get that most expensive appetizer. That's right there. Okay, so now we know that this is $9. So let's take a similar kind of approach. If this is 9, then we could put a 10 here and put an 11 here. That's a total of $30. So that means that we would need a total of 89 minus 30, $59 for the entrees. So let's just see if we can make that happen. Well, if that's 12 and that's 13 and that's 14, that's a total of 39. So we can do that if this is 20. Okay, that works. So now what are we trying to do at this point? Like, someone tell me in the chat box, the goal now is what? Yeah, make it some other number, so probably 12, right? Because it definitely can't be anything less than 11. So 12 in that box. Well, let's see what happens. So if that's 12, 10, and 9, that's $31. And you know what we can do? I mean, you can, let's finish this reasoning here, but then let's comment on how you can be a little bit more efficient here in a second. So 89 minus 31 is 58. If we do 13, 14, 15, and 16, then that is exactly 58, so that also works. So this is two different possibilities. So we're done. This is not sufficient. And so the overall here answer is A. So someone help out Sierra here. Sierra's question is this. I don't know if you guys all see that or not. So it's in the bottom left corner. Does anyone have an answer to that? Chat box. Yeah, exactly. I mean, the $16 entree is from statement 1, so it doesn't apply here. I mean, if you were using the two statements together, then that would be an issue, but you aren't combining the statements. So just be aware of that. Again, it's this kind of basic stuff that messes people up a lot. You know, like, people are good at the math part and so on, but when it comes to the basic functionality of these sufficiency problems, just make sure you are aware of that. Also, one quick note here. We generated this solution kind of from scratch here, but notice that this solution, which I'm going to put a thin purple box around here, this solution was also in our work from statement 1. So if we recognize that this, if we just looked earlier in our scratch work and saw this, I mean, this is still a 9. So that means we can also import this possibility. You know, you don't even have to work it out again. I mean, you can import this case from your previous work. Just when you do that, just make sure that you check this statement is still satisfied. Because if this were not a 9, then we wouldn't be able to use it. But it just so happened that it was. And let me give my usual answer to this last issue here. What range difficulty is such a question? There's only one good answer to a question like this, which is it doesn't matter. You shouldn't care. Because remember that you will not ever be able to, you will not be able to even come close to estimating that on the real test. So therefore, you can't strategize or plan around it, so don't try. It's just a distraction. Like, thinking about difficulty levels will never, ever, ever, ever help you in any way, and it can hurt you in a lot of ways by just pulling your brain power away from things that actually matter. So, irrelevant. Doesn't make a difference. But the point is to concentrate on how this works. So, there you go. Okay, I mean, you know, you probably have some sense from the fact that of 41 people in the study hall, exactly 3 people got it correct. So you probably have some idea. But still, it's not, you shouldn't care. Okay, any other questions about this problem? Okay, cool. Let's go ahead and move on. Maybe like one person seems to be typing. Let's move on to something else. How about this? Okay, here's a timer. Go for it. Okay, ladies and gentlemen, there are not very many answers to this problem yet. So please pick something. Again, in the next like 10 seconds, still a few of you non-responders. If you don't have anything, including some of you I know are here because you've been asking questions, Sumya, Sierra. Seems to be a lot of people whose names start with S who don't have answers. So, okay. Again, if you are Sid or Sierra or a couple other people who don't have answers yet, remember on the GMAT you cannot do that. You cannot not answer things. But gotta move on here. So here are the class responses. We kind of have lots of everything here. In fact, this may be the most evenly distributed answer profile that I've ever seen. I mean, with the exception of E, we have almost identical numbers of people picking everything. So it's interesting. It's good though. It means we can do some learning here. It means we can get some schooling that happens. So anyway, let's take a look here. So a pet shop contains 60 animals, each of which is a cat, a dog, a bird, or a hamster. How many are hamsters? So, I mean, again, it's a word problem. I mean, it's not much of a word problem, but at least it's still a word problem. So we should still organize it in whatever sort of humble way. So let's just organize like this. Cat, dog, bird, hamster. I mean, notice it doesn't really have to be much more elaborate than this. I mean, this is not anything super genius, obviously, but this is still an organizational device. It will still help. So, still a thing. I mean, it'll definitely still help you organize your thoughts. So let's take a look at statement 1. So in statement 1, we know that the ratio of cats to birds is 2 to 3. And then we know that the ratio of birds to dogs is 5 to 2. So that means that dogs to birds is 2 to 5. Okay. does anybody know? Oh, the blank page under the question. Sierra, I don't know exactly what you're asking, but I think that I think you may just be asking where to pick the answer choices. If that's what you are asking, that's what this was. So they appear under your name. Please use these. Please don't post in the chat box. If that's not what you mean, then clarify, please. But this is a menu. If you click on this, you'll see some choices. So, oh, okay. Well, all right. This is a data sufficiency problem. Okay, I think I get what this is. This is a data sufficiency problem, so you have to know what the choices mean. I mean, there are. I'll go ahead and get them for your reference. But when we have these study halls, we do assume that people are familiar with the basics. And on this type of problem, which is data sufficiency, the basics include what the answer choices mean. If you don't really know what the answer choices mean yet in data sufficiency, then we do expect that from the audience, just because we wouldn't really be able to make any progress on these problems if we didn't assume a knowledge of that. But that's what the choices mean. So if this is what you're asking about, then you just got to know these. So there they are. I'll leave them up on there for a few seconds, at least on the bottom of the box. Okay, so ratios, there's a couple of things we can do here. One way we can attack this problem is by combining ratios. Does anybody know how to combine ratios? So yeah, you want to use a common multiple, right? So you want to combine the ratios. Because the birds, we don't want two different coefficients for birds. So notice that a ratio of 2 to 3 is the same as like 4 to 6. It's also the same as 6 to 9. It's also the same as 9 to 12, etc. Basically, it's the same as 2 to 3 multiplied by any integer. So what we can do is we can just make that, because we want to make this the same for the bird so that we can combine all the ratios. So we can multiply that by 5 and express that as 10 to 15. And then same thing with the 2 to 5, we can multiply that by 3, and that'll give us 6 to 15. So this means that your overall ratio of cats, dogs, birds is 10, 6, 15. So that's your overall ratio. So now, what do you do from here? Like, remember, they still have to be integers. And why do we know that they have to be integers? Chat box. Yeah, exactly. You can't have fractional numbers of animals. So, you can't have like 2.8 cats in a pet shop. So let's look at possibilities here. Again, it's integers only. So let's look at possibilities. Well, a pet shop wouldn't really have that. So let's look at possibilities. So you could have actually 10, actually 6, and actually 15. What are the next smallest numbers you could have? Yeah, you could have 2 times the numbers in the ratio. You could have 20, 12, and 30. Let's see how these work out. Well, this is a total of 31. So 31 taken out of 60 means we have 29 hamsters. And then this would give us -2. Oops, that doesn't work. So there's actually only one possibility here, which is this first one. So there has to be 29 hamsters. So this statement is sufficient. So, but notice at the end of the day, you do have to do a step that's not algebra, which is you do have to look at whole number possibilities and ascertain that only one of them gives you fewer than 60 animals. So this is it. You got to have 29 hamsters. So statement 1 is sufficient. So that, I mean, only about 14 out of 42 of you guys realized the statement 1 was sufficient. So if you were in the majority, then make sure you try to figure out where you went wrong. Let me show you another way that you could do this, which doesn't even involve combining ratios. You could just make lists. Let's go ahead and take this over to the next page. So here's still looking at statement 1 here. You could just make lists of the different ratios. So statement 1, you could also make lists like cats and birds. That could be 2 and 3. It could be 4 and 6. It could be 6 and 9. It could be 9 and 12. It could be 12 and it could be, that's supposed to be 8 and 12, sorry. 12 and 10 and 15. Let me fix the typos. That's supposed to be 15. That's supposed to be 8. And then you could also do the birds to dogs. And then remember, the birds is the birds, so you have to pick things that are in both lists. So this could be 5 and 2. This could be 10 and 4. This could be 15 and 6. And you would just keep making these lists. So, and it doesn't take that long. I mean, you just have to make a decision. You have to just commit. You have to start doing it. But once you start doing it, it doesn't really take that long. So, and then you would find that you got 10, 15, and 6. So this is a possibility. And then your next possibility, your next matching thing would be 20, 30, and 12, which is too many animals. So, I mean, okay, there's a comment here that I just want to make a quick response to, which is this. I mean, there's two things really that I have to say in response to this one. The first thing is, as soon as you got that many unknowns, you should have stopped. Like, you should definitely not have proceeded to do any work with that many variables. It's just not a thing. Like, if you have that many unknowns, just quit. Seriously, people. Something is wrong. Something is very, 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 very wrong. Like, these problems never involve, like, incredible amounts of tedious algebra. So, yeah. And then also, don't forget that the topic of today's session is problems on which algebra is not your friend. So, that should have been a hint. I mean, yeah, that's there for a reason, ladies and gentlemen. So just be careful there. Once Albert, yeah, I mean, at some point, even if you, no matter what your algebraic approach is, Albert, at some point you're going to have to just test things to see whether they come up as under 60 or not. Like, you're not going to be able to avoid that step. So statement 1 is sufficient. But that's the whole point, is that they don't. Here, I mean, this comment, again, I mean, I understand this comment is mostly a joke, but it's still, a lot of people misunderstand the purpose of this test. Like, the entire purpose of this whole GMAT exam is to give you problems that don't submit to one approach every time. Like, that's the whole reason there is a GMAT, is that you have to be flexible in your approaches to it. So, I mean, you should just keep this in mind. I mean, this is mostly a test of whether you can attack things from lots of different angles. So, I mean, if this is a joke, then it's a joke, but there still is a serious idea behind it, which is, you know, you can't look for memorized approaches to these things. You have to just, you know, see what's going on and react. So let's take a look at statement 2. So here's the problem again. Statement 2, ladies and gentlemen, surprising amount of people stumbled on this statement. If one dog were replaced with a hamster, I mean, I don't really know how you would algebra this, but let's just think about this for a second. If you replace, remember that we're only concerned with how many hamsters. If you replace one dog with a hamster, what does that do to the number of hamsters? Yeah, it adds 1, right? So 1 more than the current number of hamsters. And then what is exactly half of the animals? Exactly half of the animals is 30. That is correct. So that's definitely sufficient, ladies and gentlemen. So, I mean, again, if you missed something here, make sure you understand what it is that you missed. Because this is hamsters plus 1 is 30. But, again, there were a lot of you. Like, here were the answers to the polling. I mean, so if you picked A, C, or E, which is a solid majority of you guys together, that means you thought that statement was not sufficient. So if you are in one of those groups, then make sure you take a look at this and see what you missed, because again, it's not a math issue. Like, whatever is going on here, it has nothing to do with mathematics. And it has everything to do with, you know, are you paying attention, and are you organizing stuff, and are you translating things in a way that makes sense? You know, like, you should always be thinking about this in relation to the desired quantity. Like, when you see one dog replaced by a hamster, you should be thinking, I don't care about dogs. You should be thinking, I care about hamsters. So you should just read this as, if I add one hamster, then, oh, hey, I have 60 animals, so I get 30. But again, focus here is a thing. I mean, if you are not focused on this issue, then you can get distracted. I mean, you should, you know, think in terms of the quantities that you actually care about. So, okay. So the overall, so this is also sufficient, so the overall answer should be D to this. Okay, Couple questions in the box. Someone says this. I don't know what this means because there's no 30 in statement 1. Like if you look back at what we got in statement 1, here's what we got. The only possible numbers of animals are 10, 6, 15, and 29. So nothing is 30 here. You may want to take a look at that again at some point. But yeah, that's not a thing. And then, will it ever happen that you get yeah, a couple of you guys already answered this one, but just to make sure we're on the same page. Will you ever get answers that contradict each other is basically the question. The answer to that is nope. I mean, practically speaking, that's not a terribly important piece of information because it's not really going to help you solve problems, but it can detect some things that are mistakes. Like if you do think that you got 2 sufficient answers and they're different, then that means that at least one of those is incorrect. So that's really the only sense in which that could help you, because if you it's not going to help you solve the problem itself. So it's not a terribly, terribly important thing to pay attention to, but it's still a thing. Okay, any other questions about this problem? Go ahead and throw them in the box. Otherwise, we will move on to another one. Okay, I think one of you is typing, so I will wait a little bit for that. Okay, why don't you try this? Schlock S, that's incorrect. The answers are 1 and 2. There has to be some overlap between the answers. So, but yeah, if you can choose it without solving, that's kind of the point, Sumya. So, yeah. Okay, here's a question. Put a timer on the board. There you go. Okay, everybody please pick something if you haven't already. Remember how the test works. You have to pick an answer. Even if you are not sure, you still have to pick something. Okay, so next 5-10 seconds, go ahead and get your guesses going. Okay, here are your responses. So it looks like you guys did a little bit better with this one. There's more of a consensus at least. So we still have 2 pretty popular answers. Let's take a look. What is the remainder when n is divided by 6? So this means, again, make sure you set out to begin with what does sufficient and not sufficient mean. So sufficient means there is only one possible remainder. Not sufficient means you can find 2 or more remainders. So, and generally the experience you'll probably have is that remainders with algebra are a little bit difficult or even impossible if you are talking about remainders with more than one divisor. Like if you're just dividing by 6 all the time, then you can make it pretty far with algebra. But here, it's a little bit tricky. So when n is divided by 9, so in general, if you are combining observations about remainders while dividing by different numbers, you should, the best way to go about this, you have the best odds if you make lists of cases. So let's just do that here. There's a lot of these in algebra is either infeasible or sometimes not even possible on. So statement 1, when n is divided by 9, the remainder is 2. So how do you make numbers that do this? Chat box? Like, how can you make this list? Okay, Paul, that's the list. Yeah, it's a multiple of 9 plus 2, right? Because this means that when you have, dividing by 9 gives you 2 left over, which means that it's 2 more than a multiple of 9. So just make sure that you can do that. If you cannot do this quickly and easily, then make sure that you can in the future without having to use some algebra formula. So it could be 11, it could be 20, it could be 29, and so on. So, but then what is the remainder? Remember, the question that we're trying to answer is what is the remainder when we divide n by 6. So this is the n possibilities, and then this is the remainder of n over 6. Well, if n is 11, that remainder is 5. If n is 20, that remainder is 2. So it's not sufficient. So yeah, n has to be greater than 6. So that's not sufficient. Statement 2 is very similar. So let's just make the same type of list. When n is divided by 4, the remainder is 1. So that's, again, that's going to be 1 more than a multiple of 4. So let's make n's, then let's find the remainder of n divided by 4. And remember that n has to be greater than 6, so we don't want to start with 5. So 9, 13, 17, 21, 25, etc. So when n is divided by 4, sorry, the question is, reminder, when you divide by 6, not 4. When you divide 9 by 6, you get a remainder of 3. When you divide 13 by 6, you get a remainder of 1. Looks like that's not sufficient. So now what we got to do is just combine the lists. So let's do that. Let's take this problem over to the next page. So here's the problem again. Because combining these in any other way is just sort of, if it were possible at all, it would be very difficult. So let's just combine those lists that we had before. So list from statement 1. So we have 11, 20, 29, 38, 47, 56, 65, 74, 83. 92, 101, okay, that seems like it's pretty far. That's far enough for me for now. And then from statement 2, so we have 9, 13, 17, 21, 25, 29, 33, 37, 41, 45, 49, 53, 57, 61, 65, 69, 73, 77, 81, 85, 89. And by the way, if anyone has any complaints up their sleeve about timing here, be honest with yourself here. This is not a very time-consuming process. I mean, you could easily make these lists on the board in about 15 or 20 seconds. Because all you're doing is you're just adding, like, you're just adding 4 over and over again. So, well, Paul, yeah, although be careful with trying to generalize that. So here's the first match is 29. The second match is 65. The third match is 101, and so on. And then if you divide by, so n, therefore remainder of n over 6. So if it's 29, the remainder is 5. If it's 65, then 6 goes into 60, so the remainder is still 5. If it's 101, that's 5 more than 96. So you get always 5. So that's sufficient. This is going to be C overall. Let me address Paul's question real quick. So, do we have to write this all out if we know the common multiple of this is 6? A couple of comments about this. I mean, if you got to be real careful with stuff like this because, like, for example, if you change a couple of these numbers, then let's see, the common multiple of 36. Yeah, okay. You're just talking about how to make the list here. Okay, then yeah, you can do that. This is a way to shorten making this list. But notice that, so in other words, the question here, I just understood what the question was. The question is, once you find this first case, can you answer, can you find the future cases by adding the least common multiple of 9 and 4? The answer is yes, you can. Although I would think for most people that would take a lot more time than just listing out these things. I mean, if you just kept making this list, this is about 4 more seconds of work, and this is like 6, 7, 8 more seconds of work, so it's like 10 or 15 seconds of extra work. Assuming that if you don't get any common cases, you have to keep finding cases. I mean, you have to have. You can't combine the statements without finding things they have in common. So, like, there's no such thing as they don't have anything in common, because the statements have to be able to combine. So, you should just keep going. Yeah, you should. So let me put the question on the board just so that I'm not kind of talking into the air here. If you, okay. The first thing is this first question. There's no such thing as this. Like, this is not, there's no such thing as not having anything in common. So if you have this happen, this means just keep looking. Because there has to be, that's the essence of combining statements, is that you have to look for the cases that they do have in common. If you don't find them right away, you just have to keep looking. And then as far as how far should we calculate, you're not going to be able to memorize a rule for this, but until one of two things happen. Until either you actually get two different things to happen, which would be insufficient. If that happens, then of course you're done right away. Or you see a pattern. And I mean, again, this is the whole point of a lot of what's on this math test, is they want to see if you can recognize patterns in things. I mean, if you can't just go around trying to memorize endless rules for things like this. I mean, you should just calculate until you feel that you have discovered what's going on. And in general, it shouldn't be very long before you reach that point. So, yeah. Albert, I don't really understand what you're asking. I don't know. I guess there's two things I don't understand. I don't really understand the question in the first place, and I also don't understand if you're asking about this problem or asking about like the entire data sufficiency section. So, need to clarify. So overall, this is C, as we wrote right there. So is the only way to know the answer. I mean, the only way you're really going to find these common values is by making these lists. That's the only feasible way to do that. There's not really any other decent way to do that. And again, I think some of you guys are not really getting the point of today's session. Like this question here, people, ladies and gentlemen, remember that the title of today's session is this. It's problems on which algebra is not your friend. I mean, so please don't keep looking for algebraic solutions to these. Like, this is not going to help you. The entire point of the session is to show you that you need a broader skill set than just that. Like, you're not going to be able to just algebra your way out of everything. I mean, that's the whole point of having this session, is to try to break this habit that some of you guys have of looking for algebra all the time, because it will not always exist. So, like, this is the whole point. There won't always be one. So just the point of this session in particular, as well as the last one with this title, is to get you to stop thinking like that. It's to get you to stop expecting there to be algebra all the time. Paul, they're probably about the same. But you shouldn't let that limit your way of thinking about them in general. So, Schlock, I don't understand what you're asking me. I don't know what you mean by pattern. So maybe you could clarify that. No, if the same question with different numbers, no, of course not. I mean, it could be any of the answer choices. So you have to investigate. I mean, you could make that be absolutely any of A, B, C, D, or E. Okay. Let's see if we can get one more problem in before we move on here. Although it seems like a bunch of people are typing things. This is a pretty good question here, so let's address this. There's really only one good answer to this, which is if you get stuck, then quit and try something else. I mean, it's really the only answer there is. I mean, if you try to do algebra on that last problem, you will very quickly run into a wall. Because you would have like, 9 times some integer plus 2 equals like 4 times some other integer plus 1. And there would be not anything that you could do with that. And so then you'd be like, oh, well, this is going nowhere. So I quit. That's a skill set you want. You want to just be able to get the heck out of there. It's the most important skill that you can have here. All right, let's try this one. This is from GMAT Prep. Yeah. Okay. This one's short, so this should not take 2 minutes. Let's put a shorter timer on the board. Go for it. Okay. So this is a quickie. Go ahead and pick something if you don't have an answer to that. This one you guys got almost unanimously. So this one, I don't really know how you're going to reasonably do this with algebra, but with this one, you just want to pick a number. I mean, if n is any prime number greater than 3, in other words, absolutely any prime number greater than 3 at all, in the whole world. So you can just pick one, and since these are number answers, as soon as you get one. So I mean, let's talk about this. If you, how many numbers do you have to plug in here? Yeah, you only need one, because it's unnecessary to do 3 numbers. Because look at your choices. Your choices are numbers. I mean, you can't have more than one correct answer. Like plugging in on this problem, plugging in one value will give one answer. So that's all you need. So I mean, yeah, if you're not confident in the work that you've done, you can try another value. But I mean, this work is not really tedious or anything. So let's just let n be 5. 5, not 6. Then n squared is 25. So the remainder on dividing by 12 is 1. So we're done, B. So how about that? Good times. So I mean, someone in the chat box, I mean, if you know these obscure facts about how to represent primes in terms of multiples of 6, but that's not the kind of knowledge that you would need for this test. I mean, if there is any problem on which that kind of thing helps you, I promise you it will also be a problem that has a very easy other way to do it like this. So, meaning if you know those things, I suppose it can hurt, but you also don't need to go crazy trying to remember that kind of stuff. Albert says this. This probably deserves to go on a new page. Is there a recommended number of tries to be confident? I mean, think about what the word confident means, and I think you already have the answer to this. I mean, if you have to memorize a rule to feel like you're confident, then it means you're not confident. I mean, you really need to develop an intuition here. I mean, it almost seems sometimes like people are doing everything they can to not develop an intuition here, which is kind of interesting. But make sure you don't go down that road. I mean, there's no rule for this. I mean, there's a couple of considerations that you might want to think about. I mean, like, obviously, if each case involves lots of work, then don't try as many of them. Like, you know, if each case is easy and fast, then feel free to try more. But, you know, like, once you see a clear pattern, in general, the test is not going to be mean to you. I mean, it won't be fake. Like, you're not going to see something where the first, like, 28 remainders are 1, and then all of a sudden, oh, it's 2. Like, it's not going to happen. So, but you really need to try to develop an intuition to this. So, true, the answer to the remainder problem was C. Okay, if anyone has other questions, feel free. Otherwise, we are just about done with this session. So thank you for attending. Just put that on the board just to make sure. That answer was C. Okay. Anybody else has a question about these problems, feel free to throw it up there. Otherwise, I'm going to close up shop here pretty soon. So thanks for attending, and Happy New Year to everyone. I hope it's a good one. Okay, let's see. Thank you. You're welcome. True, the one we just talked about was that. Okay. All right, so I think that's it. Happy New Year to all of you guys. I'm going to go ahead and kill the recording at this point. Good night and good luck. The next session is, I believe, in 2 weeks, but you should check the site just to make sure. So I will see you all soon enough.